Okay, here's some help with problem number 6 on Unit 1, Practice 3 for Physics 2. So the first thing you need to do is label your blocks. I labeled them Block 1 and Block 2. Then you want to label all the forces acting on them. So Block 2 has a force of gravity, and it's a unique force of gravity because it has a different mass. So that's why I made it Fg2. It also has a tension on it because of the rope connecting it to Block 1. Block 1, on the other hand, has a force of gravity down, a normal force up supporting that gravity force to keep it from falling through the table. It also has a tension pulling forwards because it's connected to this block that's falling, and then it has a friction force moving against its motion. The most important thing to keep in mind for this problem is to make two connections. The first connection is that the tension force on both blocks is exactly the same. And the reason why that force is the same is because it is Newton's third law. The force of tension of Block 1 on Block 2, this force here, is equal and opposite to the force of Block 2 on Block 1, this force here. Now I know they don't necessarily look opposite because you're like, well, one's up and one's to the right. But if you were to straighten this block out, it would be one to the right and one to the left. So they are equal and they are opposite. So the tension on both is the same. The other thing that's the same is the acceleration. The acceleration is also the same. So what you're going to end up doing is you're going to set up the sum of the forces, or you may be more familiar in seeing it as F net equals ma. So the net force is equal to the mass of 2 on, or 1a, and F net for 1, F net for 2 equals m2a. Now they don't have the same mass, but they do have the same acceleration, which means they will not have the same net force. So what you're going to do is you're going to set up this equation. So F m1a, and the net force would be the forces added together. So on Block 2, what forces do you add? On Block 1, what forces do you add? Then you're going to have to do a substitution type thing. What you're going to do is solve for, since you're trying to find the force of friction, you're going to have to either use tension or acceleration to do some substitution to solve for the missing forces that you have. So set up your net force equation for Block 1 and Block 2. So Block 1, what are the forces in the direction of motion? Block 2, forces in the direction of motion. Set that equal to ma, and then from there you should be able to find what you're looking for. It's a little tricky still mathematically, so do the best that you can, and if you're having trouble, let me know and we can look a little bit more in detail as far as how to do substitution if it's been a while since you've done that.